Our next topic is quadratic relations. These graphs have certain key features to them that are unique, different to what linear relations have. For the minds on, the first thing I'm going to have you do is take this table of values using this quadratic relation listed right here, calculate the y values, and then you'll go to GeoGebra and plot the points and put the graph here in this space. The idea of quadratics is the fact that they square numbers. So you'll see here that y is equal to x squared. So that means you take a number and square it. So the x values are these values listed here. What you want to do is take each of these and square them. A good idea is to do this on your own first and go to GeoGebra, graph those points and paste it in, and then come back and check and make sure that you did it correctly. Minus 3 squared, same sign positive. In fact, when you square numbers, because you're multiplying the same number by itself, you're always multiplying two numbers that have the same sign, so you will always get a positive. So minus 3 squared is minus 3 times minus 3, which is 9. Minus 2 squared is 4. Minus 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. One thing to note is that we have repeated values on the other side of 0. That's because we're squaring numbers that are the same magnitude, meaning they're the same size, but they just have a different sign. But as we just said, when you multiply a number by itself, you end up getting a positive all the time because they're both the same sign. So we have 9, 4, 1, 0, and then we have 1, 4, 9 repeated. Now what you would have done is gone to GeoGebra. So I'm going to go to GeoGebra and graph it and then put my graph in here so I can see in a visual way what this graph looks like and what its shape is. So we're going to plot the points of the parabola or the quadratic relation. You can go back and look at the table of values, or you can do the calculations again. Click this tool and we pick the point tool. So I'm going to go through and I'm simply going to do those calculations again, starting at minus 3. Remember our inputs were minus 3, minus 2, minus 1, 0, 1, 2, 3. So at minus 3 squared is 9. Once again, make sure you're right at the crosshairs so you get the point right on that spot. If the point ends up over a little, you can drag it back till it snaps into place here. Minus 2 squared is minus 2 times minus 2, which is 4. Minus 1 squared is 1. 0 squared is 0. And then remember, the values repeat themselves on this side. So 1 squared is 1, and it lines up with the other point over here horizontally. 2 squared is 4. 3 squared is 9. There. Now we have our points. Now, when you did it on your own, you may not have known how to create the actual parabola on here. So I'm going to show you how to do that now. In order to create the parabola, we're going to come over and click the 3 bars here. And we're going to turn on, using the View menu, something called an input bar. And that'll appear at the bottom of the screen. So you click this check box here, and this input bar appears. Now remember, our equation was y equals x squared. So in this bar, I can write y equals x. And just like on a calculator, many calculators, you click shift and that up arrow, which is a caret, and that means put the value up, and it would be an exponent. So I will put a 2 here. And notice now I can check my points. They actually do fit the graph that I was making. Now we'll copy our graph so we can paste it in our worksheet. Once again, you click these 3 lines, click File, Export Image, right-click on the image and click Copy. Now we can go back to our worksheet and paste it in. Then in my worksheet, I press Control V, and there I have my graph I can place in. Now, it's a little bit wide, so what I'm going to do is click the crop tool and drag these black lines where I want to make it smaller. And so I'm going to drag these in, and then I really don't need all this space down at the bottom to show the graph, so I'm going to crop this up this way. And there, now I have just the parabola, and I'm going to drag it in. Now, in order to do that, I'm going to change it to wrap, and then I'm going to click this menu here and fix in position so I can drag this anywhere. Now I can take this graph and drag it anywhere in here, and I'm going to put it in that space that I had, and then you can resize it a little bit if you want it bigger. And there we go. So there's our parabola that we graphed from this table. So now you know what a parabola looks like. And really it's called a quadratic relation, and the shape of it is a parabola. Now what I'm going to familiarize you with is the key features of a parabola. So here we have this graph. So there's my x and y axes, and here's my parabola in blue. And then I have these red lines here to mark some key locations, and then we have some points that we want to identify. So the first part is this line right here is called the axis of symmetry. And the axis of symmetry is the line that splits the parabola in half. And they use the word symmetry because when something's symmetrical, one half of it looks the same as the other. So our faces are symmetrical. And so if I reflect this across that line, so think of looking in the water and you see a reflection across the line between the water and the shore, and then you will see a reverse image of yourself in the water. This line here on this half, if I fold that over across that line, it would end up on top of this one. So each of these halves are identical. This point here you should be familiar with from linear relations. It's where the parabola or the quadratic relation crosses the y-axis, so that's the y-intercept. And again, similar to linear relations, where the parabola crosses the x-axis are called the zeros because the y value there is 0. So when I put 1 into y, so when I put 1 into this particular equation, which we don't have right now, it would give us an answer of 0. Similarly here, if I were to put 3 in to the equation that goes with this graph, I would get a y value of 0. So these are called the zeros or the x-intercepts. This line that I'm pointing to here represents the lowest value of this parabola, or if it was upside down, which they can be, it would be the highest value. And so we call this location here the optimal value. And that's a general term because the optimal value could be a maximum if the parabola was upside down, or a minimum like this one is. The value of y is at its lowest point for this set of values right here at this spot. And so we call this whole line then the optimal value. And when we're graphing parabolas, we don't usually use this line. This is simply shown here for illustration purposes to denote the bottom of all of this graph, which is the minimum in this case. And then finally, there's a point that would appear here, and right at this point, that is called the vertex. So in this case, the vertex is 2 minus 1. So it's this point right here at the very bottom of this parabola, or if it was upside down, it would be at the top, and that's called the vertex, which is similar to what we call the corner of a square or a rectangle, etc. So those are the key components or the key features of a parabola, and this is something that would be helpful if you could memorize these. We also have some other key features that we think about in terms of parabolas or quadratic relations. One I mentioned earlier is the fact that they can be opening up or opening down. We're going to edit this image here so we can put some text on here to identify these. So you click on the image and then click Edit, and that will take us to the drawing tool. So I'm going to put a text box in here, and I'm going to put it right on this line, which is a heading. This is called the direction of opening. And I'm going to move this box over just to center it using the arrow keys. And so we're also going to label each of these. So this is called open up. So the opening is at the top, whereas here the opening is at the bottom, and this is called open down. So this is open up. And this box over here, or this parabola over here, and this parabola over here is open down. Coming down below, here what we're illustrating is the zeros. So I'm going to entitle this number of zeros. And what we want to think about is just how the placement of the parabola and its relation to the x-axis impacts the number of zeros. In this first graph, notice that the parabola is open up, but the vertex is below the x-axis. So you can see here that there would be 2 zeros for this parabola. So we're just going to label that this has 2 zeros. Looking at this parabola here, notice that the parabola is such that it's above the x-axis and it's open up, so this has no zeros. And finally, this parabola here, it is open down. It could also be open up. The main feature here is the fact that the vertex is right on the axis. So in this case, the parabola only has 1 zero. So those are some key overall features of parabolas that we can group them in terms of what we would identify about a parabola to identify what's unique about it. Now what we want to do is go ahead and practice identifying the features, but we also want to put numeric values on them. Looking at this parabola, starting with the vertex is this point here at the bottom, and so its coordinates are -1 starting with the x-axis and coming over here -9. So the vertex here is -1, -9. The axis of symmetry is the line that splits the parabola in half, and again, that comes from the same value as the x value of the vertex. So the axis of symmetry is a line. Think of linear relations. The equation of that line is x equals -1, because anywhere on this line, x is -1. The equation of this line is x equals -1. The optimal value is the lowest value. This value is also seen in the vertex. It's -9. So the optimal value is y equals -9. The direction of opening, the opening is at the top of this quadratic relation. So this is open up. The zeros, where it crosses the x-axis, this first zero is -4, 0, and this one is 2, 0. Now, with zeros, we're talking about the fact that y is the value of 0, so we don't have to write the whole point. We can just say the x-intercept, or 0, is -4 and 2. Then the y-intercept, where the parabola crosses the y-axis, is at -8. At this point, it would be a good idea to try filling these in on your own, and then come back and check and see if you did it right. In this second parabola, the vertex is at 1, 5. The axis of symmetry is at x equals 1. The optimal value, where the highest point of this parabola is at 5. So this is y equals 5. The direction of opening, the opening is at the bottom, so this is open down. The zeros, where the parabola crosses the x-axis, we have -4 and we have 6. And the y-intercept is where this parabola crosses the y-axis. And in this case, we're going to need to estimate. It looks as though it's about 4.8. Now, if somebody said 4.7 or even 4.9, I would accept that. I'm going to put 4.8. Now you can go and do the consolidation. There's a few questions here for you to think about in terms of these parabolas. Some of these questions we haven't talked about specifically, but based on what you've seen, hopefully you can answer them. And then coming down here, there are a few parabolas for you to go ahead and fill in these values similar to what we have been doing.